So major positive update. I got accepted into University of Maryland's Human-Computer Interaction Masters. So I'm so excited. And I just have to work out a few things with them. And I am very likely going. So keep you guys posted on that. Shout out to their program. Now, this talk was inspired by two people, Professor Karla Hoff and then Sue Adams. Sue, at church today, mentioned that this color is cobalt. For those of you taking chemistry, you've probably heard of cobalt. I have heard at least once or twice cobalt associated with blue. But once she told me that this darker sort of color of blue is cobalt, I'm like, I'm using that word for the rest of my life. I like that word. And so then that inspired me because obviously today I found out that I got into University of Maryland's Human-Computer Interaction program. So it inspired me to think from a design angle, from a computer angle. How do computers get communicated colors, right? This is actually kind of a conundrum. If you really break it down, it's not an easy solution because red to you might mean a slightly different shade of red to another person, right? So how do you define it to the computer? So today what we're going to do is, again, there's many ways of doing this. We're just going to go into basic CSS, which is still the standard code used on how to design websites. There's many ways even within CSS, but we're just going to explore 3 ways because this is just a basic way to get you thinking about how humans and computers interact and vice versa. It's really interesting if you really put your mind to thinking about these problems. Anyways, let's go. W3 School, shout out them. The first way is just you can write out the color. Now, those of you who are thinking past what I'm going to show you probably can already detect something wrong with this, which is, what if there's a color that's not already predefined? For example, this color is cobalt defined. See, cobalt's not defined. Maybe I spelled it wrong. It's not spelled like that, right? It's definitely spelled like this. See? So for example, awesome color that Sue taught me today, cobalt, it's not defined here. So if I wanted to specify cobalt, it wouldn't be here. And then the other problem with this is, what if you don't speak English well, or English is not your first language? Do you know a color like teal? Do you know a color like cyan? By the way, I always associated this with teal. So what they define as cyan, I thought of as teal. This is really funny. I always thought this color was cyan. Wow. So the color I thought was cyan is actually teal. Sorry. Vice versa. Switch what I just said. So you see the problem with predefined words like this? Notice, right? Here are some of the defined color names. Notice there's Dodger blue. There's slate blue. But what about cobalt? Oh, now that I think about it, maybe, what if we say cobalt blue? What would this do? Nothing. Okay, yeah. So cobalt's just not a thing in CSS predefined wise, right? By the way, guys, this is called inline CSS. It's not good convention. Don't write inline CSS. This is just for demonstration purposes. For those of you who don't know what I'm talking about, doesn't matter. But for those of you a little bit more intermediate, you know to not write inline CSS. But basically, indicate what color that CSS knows you want it to change it to. According to color theory, you can make every single color with 3 primary colors. So you start out with 3 primary colors and you'll make every single color. Now, oftentimes it's red, yellow, and blue, but some color theorists say it's actually cyan, magenta, and yellow. So not blue, but cyan, and not red, but magenta. CSS, on the other hand, has a RGB, red, green, and blue scale. Red, comma, green, comma, blue, comma. I just put a 0 there, but 0 to 255. These are all the values you can put in, and we're gonna go and show you how this works. So again, the first value is the red. So look what happens if we make it all 0. Then it becomes a black. So every shade of white and gray and black is if you put the 3 values the same. See that? So if you put the 3 values the same, you'll get different shades. So for example, let's put it all the way here. Let's get to 189, 189. See that? This is a shade of gray. So if the values are the same, depending on how much or how little, you'll get different shades of white and gray and black, etc. So if we wanted only red, look at this. This is only red, right? If we wanted only green, and if we wanted only blue, see that? So by combining these in different amounts, we can theoretically get almost everything. See, here's more examples. And then you can define what's called an alpha value here. So check out what happens. This is basically like a transparency. So maybe if you combine the red, green, blue plus an alpha value, you could get everything. So this is, for example, a transparent, right? It's at 0. So 1 is the max value for the alpha. Now, some of you who've taken computer science or advanced math know that you don't have to count in tens, base 10s, as in because our fingers are 10, we got used to counting in base 10. So you get to 9 and then 10 is just 1 0. You go to the next digit, next unit. So a lot of you know computers have on and off, right? So that's how base 2 started. And then hexadecimal, base 16. For those of you who don't know what hexadecimal is, I just wrote it here. At 9, we don't go to 10. We go to A, B, C, D, E, F. So F is 15. At the 16, we then go to the next digit. There's more in-depth explanations for why computers use hexadecimal. You just have to know that hexadecimal makes a lot of things easier in computer speak. Knowing this, you can write the values in hexadecimal. So I wrote it here. You would write it with a hash. And then the reason I have an underscore is because you have 2 digits here. You have 2 digits to define the red. You have 2 digits to define the green. And 2 digits to define the blue. So these digits can be anything from 0 to FF. Every variation of this. Just think of this the same way as red, green, and blue. But now you have a little bit neater a number scale because it's in base 16. So again. Also, I forgot to say, if all the values are max, it's a white. I don't think I said that, but yeah, so like here's some examples. And then another really interesting thing is if it's FFCC99, you can just write it as FC9. So from a coding perspective, it saves time. So this next part is not necessary to know, but it's a good first principles way to think about numbers. So I said earlier, we are in decimal form. So this is the ones digit, right? Anything to the 0th power is 1. So 1 times 1, 2 times 1, 3 times 1, etc. This is the 10th digit. Again, anything to the first digit is just itself. So 1 times 10, 2 times 10, 3 times 10, etc., right? This is 10 to the 2nd digit, so 100, your 100th digit. Again, we can keep going. So this is the decimal system. It repeats every 10 and goes to the next digit. Now, we talked about binary earlier. Right, binary repeats every 2, so 0, 1, and then 0, 1, 0, 1, etc. Hexadecimal repeats at 16, so 0 to 15, and then at 16 goes to the next digit. Let's say we had a number like this, 232. How do we write this in hexadecimal? Well, since we know we're in base 16, let's divide. How many times can 16 go into 232? Well, we're going to have to do basic long division. Goes into it 1 time, so we subtract. 16 goes into 72 4 times, and you get a remainder of 8. So you have this and this. Now what do? This remainder would be your rightmost digit, and this would be leftmost digit. What is 14, guys? So we have 9, right? So 10 would be A, 11 is B, 12 is C, 13 is D, 14 is E. This is 232 in hexadecimal. And if you don't believe me or you want to check your work, you can multiply it back, right? Let's multiply this. Remember what we did, guys? So we have to write it out by its digits, right? So the ones digit, again, anything to the 0th is 1. So we have an 8 here. 8 times 1 is 8. This 16th digit, we have E times 16. E is 14, so 14 times 16 is 228. 228 plus 8 is 232. So this is how we check our work. The point of this video is not to memorize steps, not to teach you even how to do CSS. The point of this, I hope you see a grander picture. How do we define certain things, right? A lot of things are actually more cultural constructions than we might think about. How can you standardize it on a computer? Do you even want to standardize, right? I'm getting a little philosophical, but these are important questions as computers evolve, as we get more integrated with AI and technology. Which things are cultural and social constructions, first of all? And then which things do we want to keep as social constructions even when the user is interacting with technology. There's benefits and drawbacks to things like this, right? Like if you standardize it all, maybe it makes talking across cultures, across the globe easier, but then people might have to unlearn certain things. So big picture thinking, guys. With any field, a lot of I've worked in many fields. People don't think beyond the field. They also don't think as much about the implications. And what I want you guys to do if you watch this channel is think implications and think, how do the fields interdisciplinarily connect? That's why I feel like human-computer interaction is so interesting. That's why, for example, in college, undergrad, I did philosophy, politics, economics together. See the connections, see beyond just one little thing. So that's what I want to encourage all of you guys to do. So I hope you enjoyed this video. I hope this video not just made you want to look this up yourself, but made you want to think about things beyond just the code, beyond just the computer part, even just the computer science part. Thank you guys so much. Bye-bye.